Welcome back. Let's look at some examples for Chapter 16. This is video number 2, and we're going to start on page 383 and look at example 2a. So we're just going to find the expected value of a random variable where x can equal 0, 1, and 2, and the probability that x equals each one of those is 0.2, 0.4, and 0.4. So we take each of the x values and multiply it by the probability of it occurring, and then we add all those together and we get 1.2, and that gives us our expected value of x, which is the same thing as mu. So if you're asked for the mean, ask for the expected value, do the same thing. Okay? For 10a on page 383, we're supposed to find the standard deviation of the random variable. So baby sigma of x is equal to the square root of the variance of x. Variance of x is each value of x minus mu squared times the probability of x. So we'll have 0 minus 1.2 squared times 0.2 plus 1 minus 1.2 squared times 0.4 plus 2 minus 1.2 quantity squared times 0.4, and that adds up to be 0.56. So that's the variance, so we need to take the square root, and so that's going to be about 0.748. You need to know how to do that, both find the expected value and the variance. All right, let's look at page 385 and at problem 30. Okay. A company selling vegetable seeds in packets of 20 estimates that the mean number of seeds that will actually grow is 18, with a standard deviation of 1.2 seeds. You buy 5 different seed packets. Okay, so what do we know? We know that the expected value, because it's the same thing as the mean, is 18. We know the standard deviation of x is 1.2, which tells us that the variance of x is 1.2 squared, which is 1.44. All right, and that's just me thinking through the problem. For part A, it says how many bad seeds do you expect? So we need the expected number of bad seeds in 5 packets. So it's going to be the total seeds minus the expected number of good seeds in 5 packets. Okay, what we know about is good seeds, so that's what we can do is we can figure out, well, how many good seeds do we expect, and then we'll subtract that from the total number of seeds. Each packet has 20 seeds in them, so 5 times 20 is 100, and we want to subtract the expected value of x1 plus x2 plus x3 plus x4 plus x5. Now remember when it said that you don't want to use notation that makes it look like all the x's necessarily have the same value. You want to make sure you're using notation that will indicate that you're working with a random variable, and that's what we're doing there. Okay, each of those little individual values might be different. A couple of them might be the same, but they could all be different. So you need to use the little subscripts there. So that's going to be 100 minus the sum of the expected value of x1 plus the expected value of x2 plus the expected value of x3 plus the expected value of x4 plus the expected value of x5. Well, the expected value for any one of them is 18. So we're going to do 100 minus 18 plus 18 plus 18 plus 18 plus 18. In other words, 100 minus 5 times 18. So 100 minus 90, which is 10. B asks for what's the standard deviation. Variances add, standard deviations do not. So we'll find the variance first and then square root to get the standard deviation. So we want the variance of x1 plus x2 plus x3 plus x4 plus x5 because we've got 5 different packets. So that's going to be the variance of x1 plus variance of x2 plus variance of x3 plus variance of x4 plus variance of x5. So 1.44 plus 1.44 plus 1.44 plus 1.44 plus 1.44. So we've got 5 times 1.44, which is 7.2. So that's the variance. So now we're going to take the square root, and the square root of 7.2 is 2.683, approximately. All right, part C. What assumptions did you make about the seeds? Do you think the assumption is warranted? Explain. Well, in order to be able to calculate the variance, we had to assume each packet is independent of each other. So our assumption is packets of seeds are independent of each other. But if all the seeds are the same type and from the same lot, then this may not be a valid assumption. Okay, so if they were all the same kind of seeds and produced at the same time and had the same what's called lot number, so that means they came from the same source, done at the same time, then you probably don't have independence. All right, let's look at page 385, problem 38. Yay, this is about pets. You know, that makes me happy. The American Veterinary Association claims that the annual cost of medical care for dogs averages $100 with a standard deviation of $30, and for cats averages $120 with a standard deviation of $35. So the expected value amount for a dog for medical care is 100. The standard deviation for dogs is 30. The variance for dogs is 30 squared, which is 900. Expected value for cats is 120. The standard deviation for cats, there's a typo, gotta fix it. Will take me 2 seconds. So expected value for cats, there we go, is 35. So the variance for cats is 35 squared, or 1,225. Well, apparently my mistake is going to carry through a lot of slides, but that should be expected value of cats. So let's look. Okay, so for part A, we're asked for what's the expected difference in the cost of medical care for dogs and cats. So the expected difference is going to be the expected of D minus C. So the expected of D minus the expected of C. So 100 minus 20 gives me negative 20. Okay. For part B, we're asked for the standard deviation of that difference. Well, no matter whether you're adding or subtracting, you add your variances in order to find the standard deviation. So this sigma of D minus C is the square root of the variance of D minus C. The variance of D minus C is the variance of D plus the variance of C. So that's 900 plus 1,225 is 2,125. So then we take the square root to get the standard deviation, and so it's $46.10. Okay, so we're going to let D minus C equal X because we are told if the cost can be described by normal models, what's the probability that medical expenses are higher for someone's dog than for her cat? Okay, so we have, in order for us to figure out probabilities with with continuous random variables, we have to know that we have a normal model because that's what we know. Okay, if this was a calculus-based course, we could do all kinds of cool things, but for us, we need to know that they fit a particular model, and one of those is the normal model. We'll learn some others later. So let D minus C equals X. X is normal with a mean of negative 20 and a standard deviation of 46.10. We just figured that out. So the probability that X is greater than 0, we need to find the Z value, and then we need to find the probability, the normal probability for it. So if Z equals X minus mu over sigma, Z is going to equal 0 minus negative 20 over 46.10, which is going to be approximately 0.434. So we want to know the probability that Z is greater than 0.434, which gives us 0.332. Okay, guys, that's it. We'll work a bunch more problems in class, so make sure you bring your notes and your outline and your textbook. You never know which one of those is going to be most helpful to you. I will see you in class. Have a good day.